Today, class, we're going to be performing a magic experiment with my magic rainbow water. We're going to go, since I like rainbows, I'm going to go in the order of the rainbow starting with red. So watch as I pour my magic rainbow water into the cup. There's red. We're going to go to yellow. I want this one to be green right here. And then next is blue, and then purple. Ta-da! You just witnessed our beautiful magical experiment with our magic water. Our topic for today's lesson is acid and base. And we're going to be answering the focus question, how do acid and bases affect the properties of an object? And by the end of today's class, you'll be able to know why our magic worked and how it worked. Further explore our experiment on our acid and bases, we need an inhibitor, which will cause the acid and base to change colors when being added to. And our inhibitor, it's actually boiled cabbage water. You boil the cabbage and you just drain the water out, and it turns into this purplish color right here. And when you add the acid or the base to our inhibitor, it changes colors. And to know which color is an acid and base, I actually wrote a key on the board. If the color goes from purple to pink to red, then it's an acid. If it goes from blue to green to yellow, then it's a base. And if there's no major change in the color of the indicator water, then it's a neutral substance. Now, are there any questions before we move on? You back there, Goldilocks.
So I have Mountain Dew with me, and I'm pretty sure it's an acid. Can I try that out with the inhibitor water?
Well, why don't you come up and write your question on the board and go ahead and try that.
Thank you.
Now, what's the question you're asking again?
My question is going to be, how does adding Mountain Dew affect the inhibitor?
That is a very good question. When you're done writing that, you're going to test it in our inhibitor base and see if it changes the color or what color it changes into. Okay, now go ahead and try out your question.
Now, do I pour a little bit or a lot?
You can pour as much as you want.
So I'm noticing here that my Mountain Dew changed the inhibitor water from a purple to a pink to a kind of reddish color. So does that prove that Mountain Dew is an acidic substance?
Yes, it does. Mountain Dew is an acid. That was a very good question, Miss Goldilocks. And now that we know Mountain Dew is an acid, and it turned the water to a reddish color, is there anybody that thinks that they know which one of these or how many of these is a base? Yes, you.
Bleach is a base.
Well, why don't you come on up here, write your question down, and you can test that out. Write your question on the board. And can you repeat your question for the class so they know what we're doing?
My question is going to be, how does adding bleach affect the inhibitor?
Okay. And while you're writing that, I'm going to pour your inhibitor for you, and I'm going to get your bleach out. And as soon as you're done writing the question, you can go ahead and test that out.
Oh wow, it went straight from blue to almost to a green, and now it's definitely yellow. It must be a base.
Yes, it is. It definitely is a base because it turned it to a nice yellow color. Now, but like we just experimented, we found out that our bleach was a base because it went from our bluish color all the way to our yellow color. And like before, our Mountain Dew turned into a nice red color, and it was an acid. Is there anything up here that anyone thinks could be a neutral where it won't turn the inhibitor any color at all? You back there. You know which one?
I think that, I think it's alcohol up there. I think that would be a neutral.
Okay, why don't you come up here, write it on the board, and then go ahead and test that out.
Okay.
Go ahead and write your question on the board. And while you're up there, would you like to re-repeat your question for the class?
Yeah, I'm gonna go off of theirs, but I'm gonna say, how does alcohol affect the inhibitor?
Okay. And while you're doing that, I'm going to go ahead and pour your inhibitor. And I'm going to pull your alcohol out for you. And when you're done writing that, go ahead and test that out.
looks like it doesn't really change it, so. But, I think with the no major change, it'd be a neutral. Looks the same.
Yep, that alcohol actually is a neutral, and it doesn't affect the color at all.
Good.
As you see, as we just tested, our rubbing alcohol is actually a neutral and doesn't do any major changing to our inhibitor at all. Now, go ahead and grab out a pen and a piece of paper, and you're going to write down the questions that we asked, the investigations that we did, and your claim of evidence. I'm going to erase the board, and we're going to rewrite it up on the board. Now I'm going to have each one of you come up and present your notes and explain your question and your claim of evidence to the class. We'll start with you, Goldilocks. Okay, I'll put that on the overhead.
So my question was, how does adding Mountain Dew affect the inhibitor water? And for my investigation, I added Mountain Dew to the inhibitor water, or the cabbage water. And for my claim, when I added Mountain Dew to the inhibitor, it changed from blue to pink to red, proving that Mountain Dew is an acidic substance. And for my evidence, I just showed the cup with blue inhibitor water, adding the Mountain Dew, and the result is a red substance, which further proves that it is an acid.
Okay. Next up. Okay, I'm going to put this on the overhead. Go ahead and you can go over there and explain it to us.
So my question was, how does adding bleach affect the inhibitor? And for my investigation, I took a cup of inhibitor, which was the cabbage water, and added the bleach to it. And my claim was, when the bleach was added to the inhibitor, it changed the color from blue to green, and therefore it shows that bleach was a base. And for the evidence, I showed a picture of the blue inhibitor, and then you add the Clorox bleach, and it changes it to a yellow.
Very good. Okay, go ahead. Stand over there. I'm going to put this up on the board.
Okay.
And go ahead and give us an explanation.
So my question was, how does adding alcohol affect the inhibitor? And I took, for my investigation, I took a cup of cabbage water, the inhibitor, and added alcohol to it. And the claim was, when alcohol was added to the inhibitor did not change colors, and this proves that it's a neutral liquid. My evidence here, I have my cup of the inhibitor, and then I added alcohol to it, and then it equaled the same cup with more fluid in it, but no color change.
Okay, very good. Go ahead and have a seat. In class, going over our whole entire investigation in today's lesson, we're going to restate how we found out that everything was an acid or a base, which we originated with the magic trick. In each one of the bottoms of the cups, we had a different substance, everything but the Mountain Dew. And we added the inhibitor, which is our cabbage water, which is, it's a neutral color. When you add it, it changes colors to tell you if it's either an acid, a base, or a neutral. And we found out through our experiments, through our classmates, that our rubbing alcohol was a neutral, because it didn't change any color at all from the cabbage water. The Mountain Dew was an acid, because it changed to a nice red color, and our bleach is a base because it changed to a yellowish color. And we started with vinegar in our rainbow, which turned it red. It's an acid. And then we went, if we put the Mountain Dew into the rainbow, it would turn it to an orangish color. And then we went to our bleach, which turned the water, the indicator, yellow. It's also a base. Our ammonia is a base, and it turned it green. Our dish soap is a base, and it turned it blue. And then our rubbing alcohol, the last one, kept the same color as the indicator, the inhibitor. And that's how we did our magic trick at the beginning of the class. So it's not really magic water, it's the way we find out if something's an acid or a base.